Meta just released an AI model that can organize a dinner party, create a Facebook marketplace listing, debug a web app, manage subagents, and apparently decide when clicking buttons is beneath it. Meet Muse Spark 1.1. And despite the name, this is not an AI designed to help a Greek poet brainstorm album covers. Muse Spark is Meta's new multimodal reasoning model, built specifically for agents. Systems that don't just answer questions, but make plans, use tools, operate computers, write code, adapt when reality changes, and hopefully remember why they opened 17 browser tabs. What Muse Spark is. Muse Spark 1.1 comes from Meta Superintelligence Labs. It's now powering thinking mode inside Meta AI, and, for the first time, Meta is making it available to developers through the new Meta Model API, currently in public preview. The headline feature is not simply better reasoning, it's orchestration. Muse Spark can operate as a primary agent that collects context, builds a plan, and delegates work across multiple subagents running in parallel. It can also work as one of those subagents, staying focused on its assignment, using the tools it has been given, and escalating back to the main agent when something catches fire. Which, in agent development, is less of an edge case and more of a Tuesday. The million token memory. Muse Spark supports a 1 million token context window, but stuffing a million tokens into a model is the easy part. The more important claim is that Muse Spark actively manages that context. It can retrieve decisions from earlier in a long workflow, remember actions it has already taken, and compact older information while preserving details it may need later. That matters because real agent tasks are rarely one clean prompt followed by one clean answer. They are sprawling chains of browser tabs, documents, screenshots, API responses, revised requirements, failed attempts, and messages from someone who changed the plan after everything was already ordered. Computer use. And that brings us to computer use. Most computer use agents operate like an intern controlling a mouse through a walkie-talkie. Click the button. Scroll down. No, the other button. Muse Spark is trained to choose between direct interface control and automation. If manually navigating the interface is simpler, it can click. If the task involves repetitive actions, it can write a script or generate a batch of operations instead. The goal is not to cosplay as a human using a computer. The goal is to finish the job efficiently. Dinner party demo. Meta demonstrates this with an agent organizing a dinner party. The agent gathers information from messages, searches for restaurants, evaluates dietary requirements, and begins placing the order. Then the guest list changes. More people are coming, somebody else cancels, and the original plan is suddenly obsolete. Instead of blindly completing the old instructions, Muse Spark notices the new information, updates the numbers, and adapts the order. It is a small demonstration, but it represents the part of agentic computing that is genuinely difficult. The world changes while the agent is working. A useful agent must recognize that change without needing a human to restart the entire workflow. Marketplace agent. The Facebook marketplace demonstration pushes the multimodal side further. Muse Spark receives smartphone video of a bicycle frame. It identifies useful frames from the video, extracts listing photos, reasons about the product, and operates the browser to create the marketplace listing. It fills in the title, category, condition, description, and other required fields. So this is not merely image recognition, it is perception connected directly to action. Video becomes product understanding. Product understanding becomes structured information. Structured information becomes browser operations. And eventually, the collection of bicycle parts consuming half your garage becomes somebody else's problem. That is progress. Coding. Coding is another major focus. Meta says Muse Spark 1.1 can work across large code bases, diagnose complex bugs, implement features, perform migrations, and operate within popular agentic coding harnesses. It supports planning modes, goal conditioning, sub-agent delegation, tool use, and context compaction. In one demonstration, it builds a web application, takes screenshots of the result, notices visible failures, traces those failures back into the code, applies fixes, and validates the repaired application. That loop is important. Write code, run it, look at what actually happened. Realize the computer has interpreted your instructions as experimental theater. Then fix it. In the supplied coding demo, Muse Spark detects that an API has become temporarily unreachable and adds fallback behavior instead of simply declaring victory beside a broken browser window. That is the difference between generating code and performing software engineering. Benchmarks. Meta's benchmark table shows large gains over the original Muse Spark across agentic tool use, professional workflows, coding, computer use, financial analysis, and multimodal reasoning. Muse Spark 1.1 posts particularly strong vendor-reported results on MCP Atlas, JobBench, Humanity's Last Exam with Tools, Finance Agent, and OS World. But it does not win everything. Claude Opus remains slightly ahead on some computer use and software engineering evaluations, while GPT leads several terminal, long-horizon coding, and visual reasoning results. That is actually the more interesting story. Muse Spark does not need to be the universal benchmark king. It needs to offer enough intelligence, speed, tool use, long context, and multimodal capability to become a practical agent platform. And Meta's cost versus performance chart suggests that efficiency may be one of the model's strongest advantages. As always, these are Meta's own evaluations, using specific harnesses and reasoning configurations. Benchmarks are evidence. They are not magical trading cards that automatically determine which model wins your application. Safety. There is also an important safety footnote. Meta's evaluation report says the unmitigated model reaches its high-risk threshold for chemical and biological capabilities, and Meta could not rule out the same threshold for cybersecurity. After deployment safeguards and mitigations, Meta rates the residual risk across its evaluated frontier risk categories as moderate or lower. The company also reports stronger jailbreak resistance, lower hallucination rates, reduced sycophancy, and improved resistance to indirect prompt injection compared with the previous Muse Spark. For developers, the practical takeaway is unchanged. Powerful tool-using agents still require strict permissions, tool allow lists, isolated workspaces, monitoring, and the radical cybersecurity technique known as not giving the robot access to everything. The Meta model. API. Muse Spark 1.1 is arriving alongside the public preview of Meta's new model API. That may be the most strategically important part of the release. Meta is no longer positioning its most capable models only as features inside Facebook, Instagram, WhatsApp, or Meta AI. It wants developers building external agents on top of them. The model supports tool and function calling, structured outputs, multimodal inputs, parallel workflows, search, and long-running agentic tasks. In other words, Meta is entering the model API competition with something designed less like a chatbot and more like an operating system for agents. Final verdict. So what is Muse Spark 1.1? It is Meta's argument that the next model battle will not be won by the AI that writes the prettiest answer. It will be won by the AI that can maintain context, coordinate workers, inspect visual information, operate software, recover from failures, and complete an entire workflow without requiring a human to supervise every click. The dinner party demo shows adaptation. The marketplace demo connects perception to action. The coding demos show iteration and validation. And the benchmark results suggest Meta has moved from merely participating in the frontier model race to becoming a serious contender in agentic computing. Muse Spark still needs real-world testing. The model API is still in preview, and every agent looks brilliant right up until it encounters a cookie banner designed by someone who hates humanity. But this release is worth watching, because Meta is not just shipping another model, it is building an agent platform. And Muse Spark 1.1 may be the first real glimpse of what Meta wants personal superintelligence to look like when it stops talking and starts doing.